Welcome to an exploration of a classic game reimagined through Python programming. Today I'll be discussing our unique version of Tic-Tac-Toe developed using Python tkinter library. This game is special because it not only offers a nostalgic trip to a beloved childhood game, but also introduces the complexities and joys of coding a game in Python. Our game features two modes, the traditional player versus player and an advanced player versus computer mode, offering varied experiences for different players. The structure of our game is encapsulated in class called Tic-Tac-Toe. This class-based approach exemplifies the principles of object-oriented programming, a cornerstone of Python development. The root window created upon initializing this class serves as the foundation where all the interactive elements like buttons for the game, grid, and various informational labels are displayed. This setup not only aids in keeping the code organized but also allows for scalability and ease in implementing future enhancements. It's a practical demonstration of how a well structured code base can lead to efficient and effective software development. For the game interface, we meticulously designed a 3 into 3 grid layout, the heart of the tic-tac-toe game, where each cell is an interactive button. These buttons are dynamically updated as players engage with the game, marking their X or O. The interface also includes instructional labels that guide the players on how to interact with the game, and a status label that provides real time updates about the current mode and whose turn it is. This attention to detail in the user interface enhances the overall user experience, making the game not only functional but also intuitive and engaging. The essence of our game lies in logic and mechanics. Center to this is the make move function, which handles the core gameplay. It's responsible for updating the board with the player moves and checking for a winner after each turn. Our game's logic meticulously checks for wins along rows, columns, and diagonals, encompassing all possible winning scenarios in tic tac toe. This logic extends to detecting draws, ensuring that the game accurately reflects the state of play. In a two player mode, this function also alternate turns between the players, maintaining the rhythm and competitive spirit of the game. This segment of the code is a great example of how logical problem solving can be translated into a programming language to create an engaging gaming experience. A standout feature of our game is a player versus computer module. This mode elevates the game from a simple pastime to a challenging puzzle. The computer moves are determined by the min-max algorithm, an advanced concept in artificial intelligence and game theory. The algorithm delves into predictive modeling, simulating all possible moves and outcomes to choose the best move for the computer. The implementation of this algorithm was a complex task, but it significantly enhances the game by introducing a challenging and unpredictable opponent. This feature not only makes the game more engaging, but also demonstrates the application of AI principles in gaming development. To enhance user experience, we integrated game reset and exit functionalities. The reset feature, initiated by the press of a key, allows players to start a new game without losing the overall session data. This functionality is essential for keeping players engaged, offering a quick way to restart the game while maintaining a sense of continuity. The exit feature, also key activated, provides a smooth and user friendly way to close the application. These features highlight the importance of thoughtful user interface design in software development. In summary, this TikTok game is a testament to the versatility and capability of Python programming, from creating a graphical user interface to implementing complex game logic and integrating AI algorithms. This project touches on multiple aspects of modern programming. It's an exemplary model of how a simple concept can be transformed into a educational and entering software application. Upon running, we can see a graphical user interface. So first we need to select the box where you want to start the game. And to start human versus computer game, we need to hit the spacebar keyword. So upon hitting the spacebar, we can see that AI is making its own moves. So now we can play the game. Now we can see that the AI has won the game. To restart the game, we can hit the R keyword, and to exit the game, we can hit the E keyword. So upon exiting the code, the data has been saved, and so upon saving the data, we can make visualizations of who has won the game so far. So we can see that the AI has won the game in the bar chart and the pie chart. So we can even play multiple games and we can see who has won the game, or if it's a draw, or if the human has won the game using the bar chart and pie chart. So, having delved into intricacies of our tic-tac-toe game code, we've seen how programming concepts come to life in creating an engaging game. From the use of Python and the tkinter library to the implementation of game logic and AI algorithms, our code forms the core foundations of this project. Now let's shift gears and delve into another crucial aspect of our project, the presentation. This will give us a comprehensive view of the project, including our team's collaborative efforts, the project goals, the user interface, and the additional features that makes our tic-tac-toe game unique and enjoyable. Let's take a step back from the code and look at the bigger picture, how all these elements come together to create a game that's not just functional, but also fun and engaging. Let me introduce our team. Myself, I'm Revant Paineni, joined by Sridhar Mundla and Asif Ali Mangan Sheikh. Each of us brought unique skills and perspectives to this game, allowing us to create a well rounded and sophisticated game application. Our project brings the classic TikTok toy game to life through Python programming. We focused on design, code, and visualization to make the game interactive and user friendly. Our goals were ambitious yet clear. We aim to create an engaging tic tac toe game in Python, accessible for human to human and human to computer gameplay. We also integrated a computer opponent using the min-max algorithm and included game statistics for a richer experiences. Our game interface is the centerpiece of this project. It includes a 3 into 3 game board interactive buttons and informative labels. Here's a screenshot showing these elements. Notice the attention to detail in design for an intuitive user experience. Playing the game is straightforward. Players can toggle between human and AI opponents using the space keyboard. The R key allows for restarting the game, and the E key to exit. These simple controls make the game accessible to everyone. Coming to game logic, understanding the game logic is crucial. Players alternate turns, placing X's and O's on the grid. Winning requires aligning three symbols in a row, column, or a diagonal. A filled board without a winner results in a draw. Playing against the computer adds a unique challenge. The AI uses the min-max algorithm to strategize its moves, offering players a competitive and unpredictable gaming experience. Our game tracks statistics such as wins by player X and player O and the number of draws. These stats add a competitive edge and allow players to track their performance over time. Now, coming to visualizations, the pie chart provides a holistic view of game outcomes with colors representing wins and draws. This visualization helps in understanding the overall balance of the game results. And we also visualized our game using bar chart. Red bars represent player X wins, blue bars for player O wins, and green bar for the draws. This visualization representation helps players quickly grasp the game dynamics. So now coming to game flow, players turn. Player during players move, there we need to click on empty cell on the game board to place their symbol. It's either X or O. Now coming to the computer turn, when the AI takes its turn, it uses the minimax algorithm for strategic decision making. The AI evaluates potential moves to maximize its winning chances or to force a draw. Our game includes convenient options for restarting and exiting. We need to press R to begin a new round or E to close the application, ensuring flexibilities and ease of use. We are proud to present our deliverables, well documented source code, an executable game version, and a user friendly graphic interface. These components are integral to game's success and user experience. In conclusion, this project was a blend of creativity, technical skills, and teamwork. We developed a functional and enjoyable game with an AI opponent and an intuitive graphic interface. This project showcases our programming skills and designing capabilities. Thank you.